Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we'll continue our look at fractions. And we want to keep in mind that our goal for your child is to be mathematically proficient, and to be mathematically proficient or excel in mathematics, they need to be flexible. They need to understand how to come at problems from multiple angles. Now, in previous videos on fractions, we've talked about the fraction kit, and I'll leave links below in the descriptions below to give you that fraction playlist, and you can look at how we make the fraction kit and making fractional units, all of those pieces. But the kit typically is made out of construction paper. Just very quickly, you notice I don't label my pieces. That's purposeful. Once they're labeled, your child just needs to read the label. When they're unlabeled, they'll have to decide what the name of that piece is by comparing it back to the whole. 2 pieces equaling the whole, each piece is 1/2. 6 pieces equaling the whole, each piece is 1/6. So we embed practice by not labeling. And as I've shared before, I purposely don't use commercial pieces that are pre-labeled, because it just becomes a reading activity, and we want them to have that practice for making fractional units. I have also shared a video where we've looked at fractions on a number line and different ways to look at equivalency by looking at how we name the same location. So we'll look at those 2 different models for comparing fractions, a number line model and an area model, essentially, because those strips of those fraction pieces, or if you use circles or a rectangle that has a width to length comparison that's a little closer, you will see just the ways that we can use those different models to compare fractions. Now, when I learned how to compare fractions, everything was get a common denominator. We learned about least common multiples, so getting the most efficient way to, in the end, have your final answer in simplest terms. So it was always a like denominator. But when we look at it and really think about comparing fractions, there will be problems that are like denominator ones. There will be problems that are like numerator type problems. And these 2 types of problems can be easily done mentally. They don't require that additional computation. And then we also have the unlike numerators and denominators. Now, as we're looking through this video, I'll show you some different techniques and what is involved in the understanding of it. Because remember, mathematical proficiency involves conceptual understanding also. It's not just the mechanics for getting answers. So, unit fractions and understanding what a unit fraction is very important. So unit fractions have numerators of 1. 1/8, 1/3, 1/4, 1/10. They are those fractions with numerators of 1. Now, when we get this then to do comparisons, it's important that your child really understands that meaning of numerator and denominator. When I learned it, the denominator told us how many pieces we cut something up into, and the numerator told us how many of those pieces. That's not incorrect, but what we want to think about is the denominator. Think about the unit fraction size, 1/8, and we have 5 of those 1/8 pieces. So notice another way to read it. I can read this as 5/8 like I always have, but I could also read it as 5 1/8 pieces. Reading it the second way helps us when we want to do comparisons. So if I compare fractions with like denominators, I have 3 1/8 pieces compared to having 5 1/8 pieces. Do you see what we're comparing is just how many of the pieces we have? The more pieces we have, the larger the fractional size. So if I'm looking at my fraction kit, and notice how I've used a dashed line to show the whole. That's a technique your children may be using to draw some fractions. Also, not just shading in, but you can see I have 3 1/8 pieces compared with 5 1/8 pieces. Okay, 3/8 compared with 5/8. If I'm looking at the number line version, with convention, typically, numbers get larger as they move to the right, or if we're doing a vertical number line, numbers get larger as we go up, right? As we go up that vertical number line. So in this case, 5/8 is to the right of 3/8. That would be the larger value. Now, if your child is having a hard time drawing the inequality symbol the correct way, notice how I put 2 dots next to the 5/8. Essentially, what we would ask your child is, which is larger, 3/8 or 5/8? And based on the two models we've looked at, we know 5/8 is larger. We put 2 dots next to the 5/8, 1 dot next to the smaller number, and then we connect the dots. Okay, we don't need to use those stories of alligators eating bigger numbers or other stories. It's very conceptually sound too. 2 dots next to the larger number, 1 dot next to the smaller. If they're equal, 2 dots next to each, and then we connect them and we get the equality symbol. Okay, now like numerators is another option. With like denominators, you had the same size pieces and you were comparing the quantity of those, right? If I have 3 of those 1/8 or 5 of the 1/8. In this one, we have different size unit fraction pieces, but we have the same number of each. So in this case, I've got 1/8 pieces, size pieces, and 1/6 size pieces. And if we've done a lot with fraction kits, your child should understand that the 1/6 is a bigger piece than a 1/8 size piece, because I've cut that whole fewer times. Those are going to be bigger pieces. So if I have 3 of the 1/8 piece, that's going to be smaller than having 3 of the 1/6 size pieces. Okay, we can show that with our fraction kits, right? So we have those different size pieces. If I know that 3/6 is 1/2, I already know that 3/8 is less than a half. So I can do that reasoning using 0, 1/2, and 1, those benchmarks, okay? If I look at my number line, same idea, 3/6, right? And I can see here how I've cut that into fewer pieces, so each piece is larger. And again, 3/6 is going to be greater than 3/8. I can draw my inequality symbol again. If your child needs to use the 2 dots, 1 dot, great. Okay. Now, the other is unlike numerators and denominators. And we don't want to underestimate the importance of reasoning through things. Even just looking at this, can you reason through and think about which is larger and why without getting a common denominator, without going to 56, right? So if I think about it, and if you did, pause the video and come up with your reasons and try them out with your child. But for me, that 5/8, see, if I know 1/2 is 4/8, well, I'm more than a half on the 5/8. And 3/7, well, 3 is half of 6, so 3/7, that's got to be less than a half. So I know 5/8 must be greater than 3/7. So it's relative position of the fractions. Relative size, but if I think in terms of that number line, 0, 1/2, and 1, where are these fractions falling on that number line? I can reason it through. Okay, so another example, 7/8 and the 5/6. Now at 7/8, again, pause the video and come up with your reasoning as to which is larger. But at 7/8, we're 1/8 away from 1. At 5/6, we're 1/6 away from 1. That's a bigger space away because we know those 1/6 pieces are bigger, those cuts. So 7/8 must be greater. Okay, so there's a lot to do with reasoning. There's a lot to do with understanding the relative size of those unit fraction pieces. So we don't want to underestimate that, whether we're talking about a kit, a regional model, an area model, or the number line, that linear model, is really understanding the size of the pieces, not just going through symbol manipulation, numeric manipulation immediately. A lot of these can be done mentally when we can reason through these ideas. I hope that helps. you think about how to help your child with comparing fractions? If so, please give it a thumbs up. Please share with others, and I hope you'll consider subscribing to the channel. I really do appreciate it when you do, and it really does help the channel out. It's easy to do. You can subscribe, click on that notifications bell so you'll know when other videos become available. Thanks so much for watching.